All right, so when we left off, we had just figured out that to put the equation of a circle, all I just need to do basically is to have x times the radius, x equals the radius times the cosine t, and y equals the radius times the sine of t. So that's pretty cool. But that was when it was centered at the origin. And then this question over here, F, asks you, what happens if I want my problem centered at -2? -2, 3. So, I don't know. I remember, though, when I was graphing equations that there was something weird. If I wanted to do the center, that I just do everything opposite. So I'm going to play around. I still want my radius to be 6, but I kind of remember that everything was like opposite of how the center was when my teachers taught me about conic sections and stuff before. So I'm going to do the opposite of -2, which is +2, and I'm going to add that to the x. And I'm going to do the opposite of 3, which is -3. And I'm going to see how that changes things. So now when I graph it, it's still my circle, but it looks like it got moved to 2, -3. And so the center is right there at 2, -3. Oh, is that what I wanted? I don't remember. No, it's actually exactly opposite what I wanted. I wanted -2, 3. So it's even easier. Wow, I don't even have to really think about it. It's just 6 times the cosine of t minus whatever the center is. And then y is equal to 6 times the sine of t, whatever the center is there. So then if I wanted to do the second part of the problem, center it at 4, -1, I think that you can figure that part out. You try. Okay, now this one is kind of cool because this is how we were working on equations of lines last week. So when we talked about the parametric equation for a line in vector form, remember we said, okay, we need a point. So I'll take this one, -5, 2, plus some r thing. But instead of r, let's call it t. It kind of makes more sense today. And then here I needed a slope. So all I have to do for the slope is terminal minus initial. So 7 minus -5, or sorry, 2 minus -5 is 7. And then -6 minus 2 is -8. So that's what we were doing with vectors last week. But we want to have a parameterization, which means I need a pair of equations. So instead of thinking about this as vector u, I can rewrite this vector in component form x, y. And then that makes it pretty simple because I just take the x parts, x, x, x. So my x will be -5 plus 7t, and my y will be all the y pieces, 2 minus 8t. Simple, simple, simple. That's so cool. Now, if you did your slope the opposite way and you had -7, +8 here, and you had -7, +8 here, it's really the same thing. So you don't have to worry about that. And if you put the different point here to -6, when you graph it in the end, it's going to turn out to be exactly the same. So you're fine. Alright, so the only thing that's going to make you think a little bit more today than you already have is this problem here. That's why it says think about it. Oh, let's think about it. Okay, put on your thinking caps. Ready? Is it situated? Okay, sorry. So find the values for t for each quadrant if x is equal to 3 minus the absolute value of t and y is equal to t minus 2. Alright, I have no idea what whoever made this worksheet, whatever they're talking about. I just learned how to do this. How am I supposed to think about this? People are crazy. I do have this graphing calculator, so I think what I'm going to do is graph that. So 3 minus the absolute value of t, so remember math, num, absolute value, t. Oh yeah, t, sorry, xt theta. I hope you saw that earlier. Otherwise, you're going to be really mad. Okay, t minus 2. And I'm going to push graph. And I get this weird thing here. Okay, so it's like a sideways absolute value graph. So the question is asking me, find the values of t for each quadrant. So what it means is there's certain values of t that are making this relation go into each quadrant. So this is in the fourth quadrant, this is in the fourth quadrant, third quadrant, this little part in the first quadrant, and then this part up here in the second quadrant. So what I need to do in order to be successful at this problem is figure out all the places where the graph crosses the XY coordinate plane. So it looks like it's 1, 2, 3, 4, 5. 0, -5, is that right? 1, 2, 3, 4. So it goes like this. So this point down here, I'm just reading it from the graph, is 0, -5. This point right here is 1, 1. This point right here is 0, 1. And those are all the places where the graph is like changing values, right? So what I have to do is kind of a modified substitution system. So first of all, I'm going to trace and see what happens when I trace. And when I put that t is equal to 1, I have the point -1, -2. That's right here. So when t is equal to 1, I'm in the fourth quadrant. What if when t is equal to 0, I have the point 3, -2. So still over here in the fourth quadrant. So somehow I have to be able to figure out what's happening at when t is equal to these values. Like what is the t values going to be equal to? So what I'm going to do is I'm going to plug this in for x and y and solve it for t. So when y is equal to -5, so y is equal to t is, oh, nope. When y is equal to -5, I want to figure out what t is. T minus 2. So t is equal to -3. So all I did was I just plugged this point in for y value right here. So now I'm going to go back to my calculator and I'm going to trace it. When t is equal to -3, oh yeah, I'm right there on the y-axis. So I'm at the point 0, -5. So then what happens when t is -4? Oh, then it's still in the third quadrant. So it looks like when t is less than -3, less than or, well, I guess not equal to, just less than -3, we're in quadrant 3. And then when t becomes more than -3, that's what we were just looking at, right? So when t was more than -3, we were in quadrant 4, so that's where we switched over here. But I have to figure out what t value this is right here. So what I'm going to do is I'm going to plug in 1 for y. So when I plug in y is equal to 1, I'm just going to plug in this point right here. I get t minus 2, so I get that t is equal to 3. Now I'm kind of concerned because if these both have the same y values, so if I do a trace at 3, see how this t value up here, this is t equals 3, not this one that I was looking for down here. So there has to be another t value. So that's when I have to use this x part. And I was resistant to using the x piece because this had the absolute value and it was kind of freaking me out. So now I'm going to solve this part for t. So I'm going to, x is equal to 1. So 1 is equal to 3 minus the absolute value of t. So it looks like t, the absolute value of t equals 2. So t is equal to plus or minus 2. Do you guys remember that? So now, if I plug in negative 2, I think that I'm going to be right there on the x here. Oh, I already know that that's still in the fourth quadrant. And if I plug in positive 2, there I am right there. So when t is less than 2, from negative 3 to 2, I'm in quadrant 4. And then from 2 to 3, I'm in quadrant 1. And then anytime t is greater than 3, you're in the second quadrant. Okay, so that's by far the most challenging problem for today. I'm sure we'll have to go over more problems like that when I come back tomorrow. But I hope this was helpful, and I really want you to go online and find your book online and do these problems, please, on parametric equations. Get some practice. Okay, bye. I'll leave this answer key for you. Have a great day. Bye.